Hey guys, Buildzoid here, and today we're going to be doing another video on the Nvidia 12-volt high failure rate connector because Der Bauer released a excellent video investigating the card that was recently in the news for, having the melted connector. He actually managed to get his hands on it. And also he did some of his own testing with with his own 5090 Founders Edition, and he got this thermal camera footage from that testing. And this thermal camera footage made me go, oh, that's why the 30 series doesn't melt. And the 40 series does, and the 50 series will. So, I'm not going to spoil his video. You should go watch it. But, yeah, anyway, the big difference between the 50 series and the 40 series, and 50 and 40 series is the same thing. But the difference to like a 3090 Ti is that on a 3090 Ti, this 12-volt high power connector is actually treated as 3 separate 12-volt sources. Whereas on a 5090 Founders Edition, there is one shunt resistor for that entire connector. This is, like, as far as the card is concerned, this could be 1 wire instead of 6. Whereas with a 3090 Ti, it needs to be at least 3. Okay? Like, it needs to be at least 3 wires on a 3090 Ti. On a 5090, it could just be 1 wire, and the card has no way of telling the difference. So, let's switch over to GIMP, and I'll show you the actual, like, how the circuitry is set up on these cards. So, first things first, let's say you have an Nvidia GPU with 3 8-pins or 6 pins, right? Now, fun fact about the 6-pin is that it's rated at 75 watts, and minimum spec is that it has 2 12-volt connections. But generally speaking, your power supply is going to have a 6-pin with 3 12-volt connections, and an 8-pin also only has 3 12-volt connections, but an 8-pin is rated at 150 watts, which basically means that out of all of the power connectors we're looking at today, the 6-pin is the most underspec'd. Like, the real-world current handling capability of a 6-pin power connector on a good PSU is way beyond the 75-watt, like, 6-pin power standard, which I find kind of funny. And then, of course, we have the 8-pin, which is 150 watts with its 3 wires in it. Now, if you have an Nvidia GPU, the way that, like, with 3 8-pins or 3 6-pins, the way this is going to be wired is there's going to be 3 shunt resistors, 1 for each of the power connectors. On the power supply side, if you have a single rail PSU, they're all in parallel. The PSU has no way of telling which power connector is outputting how much power. Unless, well, technically you can get some like high-end digital power supplies that might have per power connector power monitoring, but they're still not going to have current balancing. And they might have a per power connector current limit, but they're not going to have current balancing. Okay? So, yeah. Anyway, so generally speaking, your power supply has no idea which connector is doing what, because on the power supply side, they're all connected in parallel. On the GPU end, however, you have a shunt resistor for each of the power connectors, and what that means is that, like, if we cut the wires like this, then the card won't run because there's, like, this is functionally the same thing as, like, that connector not being plugged in at all. Because, yeah, that's, if you unplug it, it's like if you cut all of the wires. But what you could do is you could cut 2 of the wires, and the card will still run. And you could do that on every single one of the connectors, and yeah, the card is still going to work in this, in this setup, the card is still going to work. And now you're technically overloading, like, ideal conditions, it would be 3 times 50 watts, right? So you'll have 50 watts through each of the wires. If you cut the 2 of them, you're going to have 150 watts through one of the wires. So, not ideal, but if you have a high-end power supply, your 8-pins are going to be using it depends. Really high-end power supplies will use 16-gauge cables for even, like, your 8-pin power connectors. And 150 watts through a single 16-gauge cable, you're fine. Through a single 18-gauge, I think it's slightly overloaded. And I believe you might be able to find some PSUs that use 20-gauge wires, and those should be thrown away. But Anyway, so in this situation, right, like worst case scenario overload is that you put like 150 watts through one of the wires. Not ideal, but yeah. And if you try to do anything worse than that, the card literally won't run, right? Because you've just disconnected one of the power connector. Like you've completely you've completely disconnected one of the power connectors. Other than that, because of this setup over here, the card can actually current balance these three connectors separately. And the way this is done is that, let's say you have a 12-phase VRM, let's say 12-phase V-Core VRM, and let's say everything else on the card runs off of the PCIe slot for convenience. So let's say you have a 12-phase. You're going to have like 4 phases on this shunt resistor, 4 phases on this one, and another 4 phases on the last one. And if all the phases are perfectly current balanced, which generally the voltage regulator will try to maintain pretty even current balance across all of the power stages for efficiency reasons, you don't really want to have one power stage handling like 5 times the current of another power stage, because peak efficiency is usually reached at, like, let's say you have like a 60 amp power stage, peak efficiency is probably somewhere between 10 and 20 amps. So, if you have a 12-phase VRM, you don't really want to have 60 amps going through one power stage and nothing going through all of the other ones. You want to have 10 to 20 amps going through every single one of them. So, in a typical VRM, your phases are going to be, pretty well balanced, which also means that, if you have 4 phases per shunt, it's also 4 phases per power connector, which means your power connectors are going to be relatively current balanced as well. And in fact, Nvidia GPUs historically went above and beyond to maintain current balance across the power connectors by doing things like adding MOSFETs onto the board to dynamically change which phases are connected to which shunt resistors. So basically, you'd have like a switching part so that you could like a 980 Ti, for example, would have the ability to switch some of the phases from the 6-pin over to the 8-pin, depending on whichever like connector was the most closest to reaching the power limit or most hitting the power limit, right? So this setup, you have like per connector current balancing, and worst case scenario, you can overload one of the wires by 3 times the expected load, right? So that's that. Then we get to the 3090 Ti 12-volt high power implementation, 3090, 3080 Ti, 3080 Founders Edition. So all of the 3090 Ti's have this setup, and then for the like non-Ti, like 3090, 3080 Ti, 3080, it's just the Founders Editions, right? Because all the other cards were using like 2 8-pins or 3 8-pins or maybe a 2 8-pin, 1 6-pin setup. I don't think I've actually seen one of those, but that was a thing for 980 Ti's in the past. But anyway, so these all use 12-volt high power connectors, and the way that is wired up is, again, we have 3 shunt resistors. Again, you're going to have like some phases connected to this shunt, some phases connected to this shunt, some phases connected to this shunt. Also, these actually would have all the extra current balancing circuitry, so like MOSFETs for shifting which phases are connected to which shunt resistor. But for the sake of like, melting the power connector, what's important is that we can cut this wire and the card keeps running. But if we cut both of these wires, well, that disconnects this shunt resistor, the card doesn't run anymore. It literally won't even turn on. So the worst thing we could do to a 3090 Ti, as far as like cutting wires goes, is something like this. And, previously it would have been 6 times 100 watts, right? Like that would be assuming that all of the wires are perfectly perfectly current balanced, and the card is running at the limit of the power connector. You would have 100 watts going through each of the wires. Now, this worst case scenario is 3 times 200 watts, right? Because we cut 3 of the wires and we have 3 wires, and those are being current balanced by the GPU because of the way the shunts and the phases are set up. So here we have a 2x overload. This is actually kind of less of an overload than the, 50 watts going to 150 watts through one wire. But funnily enough, like the 12-volt high power connector still uses 16 gauge cables. So like you could get a power supply where your 8-pin is like your 3 8-pins are actually just way better than a single 12-volt high power connector. But the thing with, like, I guess one of the issues Nvidia wanted to solve with the 12-volt high power spec is that the 8-pin, 6-pin spec was kind of loosey-goosey, right? Because you could get 6 pins with 2 12-volt wires, you could get 8 pins with 3 16-gauge wires, or 3 18-gauge wires, or I believe 3 20-gauge wires. Again, if your power supply has 20-gauge wires on the 8-pin, you should probably throw it out as far as I'm concerned, but I do believe that's still within the spec, unfortunately. Anyway, so yeah, so that's the 12-volt high power setup on the 30 series. Now let's get to the 4090s and the 5090s. And these do this. And if you're looking at that and going like, man, that looks incredibly stupid, that's because it is. So first, all of our wires come in, get combined into one big just blob of 12 volts. Then that goes through 2 parallel shunt resistors. I don't know why there's 2 of them. And then that gets combined right back into one big blob of 12 volts. So in this scenario, you could cut like 5 of the wires. And you would go from 6 times 100 watts to 1 times 600 watts. And then, of course, this is going to catch fire. Also, even if all of your cables are plugged in, there is physically no way for these GPUs to current balance the connector, because as far as the GPU is concerned, it is one blob of 12 volts. And quite frankly, even if this connection over here didn't exist, it wouldn't change anything because, again, on this side, it's still one big blob of 12 volts. Right? Like, you need this kind of, like, separate, like, completely... like, the phases need to be pulling power like, from different sets of pins. The pins cannot get combined on the board if, like, however many pins you want to current balance... that's how many pins have to be on separate, like, connected to different phases. So yeah. So that's fun. You know, I'm surprised that Nvidia, who was so, like, hell-bent on maintaining, like, perfect current balance between their 8 pins and 6 pins on their, like, 980 Ti's and 3090s and all of these older cards, that they had, like, a bunch of extra circuitry to, like, shuffle phases around from one connector to the other connector. That, you know, they worked their way towards this in the end. Like, I just find that insane. It's just like, they used to care so much about maintaining proper current balance between the power connectors. And then they went from that to this. Oh, and then you get to the 5090 Founders Edition, where apparently 2 2-milliohm shunt resistors cost too much money, so now we just have 1. Now, functionally, this doesn't change anything. Like, these two setups are identical, but I did want to draw them both out because if you look at a 5090 Founders Edition, it is very obvious that it does only have 1 shunt resistor, not 2 of them. But in terms of, like, electrically what this does, it's the same thing. Electrically, this is identical. Neither of them can be current balanced. Both of them can have 5 of the wires completely disconnected, and the card will keep functioning, at least until the cable catches fire. And then we get to the 4090 Matrix and the 5090 Astral. Now, Asus looked at all of the issues with Nvidia's beautiful connector, and decided that, like, sure, we can't current balance it, but at least we can give the user a warning when the connector is about to melt. And so they added this glorious block of extra shunt resistors after, like, in between the Nvidia current monitoring block and the power connector, right? The power connector would be, like, somewhere over here. And so what this means is that now, if you cut one of the wires, the Asus software will tell you, like, hey, one of your wires is, like, not doing anything. Like, there is 0 amps flowing through that cable. You should do something about that, because it's probably not plugged in correctly. So, yeah, unfortunately, the Asus solution does not solve the issue of current balancing the wires because it's still one big block on this side. Right, like, it's still just one big 12-volt block on the other side, so, yeah, you're not going to current balance that anyway. But at least you're going to get a warning before the cable decides to melt. right? Because again, like, yeah, if you cut all of these, I think the card will actually probably still turn on. Because again, I don't know how exactly Asus implemented this. Like, personally, I think they should probably just not let the card turn on if it detects something like this, but I don't know if that's what they actually implemented. It's certainly not required by Nvidia because Nvidia thinks this is okay and this is okay. That's literally what they have on their Founders Edition, right? So, how this actually works depends entirely on what Asus felt like implementing, and I don't know what they did. Um, but yeah, ultimately, like this Asus setup, it allows the card to detect if there's something wrong with the current balance. It doesn't allow the card to actually fix it. The user has to fix it. The user would have to power down the card and then like fiddle with the connector until the Asus software tells you, hey, current balance has been achieved. Please stop fiddling with the connector. And then as soon as you let go of it and the cables sag, it goes out of whack again. So yeah, this connector is stupid, is what I'm getting at. Like, this connector is just completely stupid, and the way that Nvidia, like, this, like, I finally understand, like, why doing this made such a difference to the failure rate of the connector. Because, like, when the 12-volt high power melting connector stuff started happening, like, a lot of people were like, but why didn't, like, 3090 Ti's melt, right? Those had a 450 watt power limit. Why didn't those melt? Well, and at the time, I thought it was like, oh, well, maybe because like 3090 Ti's are very unpopular, right? Like, I can't imagine a lot of those sold. But I think actually the reason that they didn't melt is because they just had a better way of dealing with the connector, right? And then we get to the 4090 and 5090, and it's just like, yep, like you could literally disconnect like 5/6 of the connector and it'll keep, like, the card will keep running because it literally has no way to detect that 5 of the cables aren't plugged in, right? Um, so, and like the reason I'm bringing this up is like similarly, if you have poor contact on 5 of the cables, the card has no way of detecting that. Like, it can't detect if you disconnect them. It really can't tell if they're like slightly not touching properly. So yeah, this connector is just stupid. And what I find absolutely insane is that there's like 4 extra wires in this connector, right? You have those like sense pins, which are not used for like actually sensing the condition of the connection at all. They're used for like what they're supposed to be used for is that the power supply can tell the GPU, hey, I'm like a low end power supply. Please don't try to pull 600 watts. Because previously with the 8 pins and 6 pins, the idea was like, well, if you had like a 400 watt power supply, it wouldn't have 3 8 pins on it, right? Like that was the logic back there, back then. But with the 12-volt high power connectors, like, well, yeah, you could have a 400 watt power supply with a 12-volt high power connector on it. So we need some way for the power supply to tell the GPU, hey, please don't pull 600 watts because I'm not built for that. So that's great. I don't know why we needed 4 wires for that, though. So, well, actually, I think the reason it's 4 wires is like there's like a whole bunch of levels to how much power the 12-volt high power connector can deliver, and I think it's like 150, 300, 450, 600, something like that. I still think it's stupid. These were better connectors. They had more, like, they just had a bigger safety margin. This was kind of okay, and this is just stupid. Like, this right here is just like, yep, like, this is just gonna, like, these are gonna keep melting forever. Because, like, now it makes sense to me why the 3090 Ti's didn't melt. Because they actually, they forced the connector to be current balanced. 5090s and 4090s just don't. And so if the cables don't make perfect contact, they melt. What a stupid connector. And like, and the thing I don't get is like, this is Nvidia. Like, they had so much extra circuitry on their cards for maintaining current balance, and then we get I guess that's why they wanted the 12-volt high power connector so much, was just like, we need a connector that doesn't require a bunch of extra current balancing circuitry. Well, turns out, unless the connector is literally one wire, you're not getting that, evidently. Like, if you have multiple wires, you should probably try to current balance them a bit. Because you can't just assume that the connector is going to be perfectly plugged in every single time. So, yeah. Dumb connector. Really dumb. And just like I feel like if it's like, oh, we wanted less board space or something, then yeah, you could have taken because the 12 volt high power is like a higher density connector. So it's like, yeah, you could have taken the 12 volt high power and maybe like made a mini version of the 6-pin, right? Like a mini 6-pin, and it's always 150 watts. It always uses 16 gauge. And then you could have 1 6-pin, 2 6-pin, 3 mini 6-pin, right? So, and it would still take up less space than like probably 2 8-pins. And you'd still have you'd have this current balancing setup, or you could make the 6-pin 200 watts or something. Like, it would still be less ridiculously overloaded than this abomination, or like this abomination over here. This is actually relatively okay. This isn't. This is bad. Terrible. Why? So, but yeah, evidently Nvidia got really sick and tired of trying to current balance the connector, so now the connector just melts. Progress. Anyway, so yeah, that's it for the video. Hopefully you find this somewhat interesting. Also, definitely watch Der Bauer's video. It's really good. Yep. I wish more tech creators could make videos like that. I'd be less bored on YouTube. Anyway, that's it. So thanks for watching. If you'd like to support the channel, there are links in the description that you could check out. That would be very much appreciated. And that's it for the video. So thanks for watching, and goodbye.